Hello, everyone. Whoa, it's a little bit hot. Well, I'm glad to see so many people here. And so the topic of today is Gradle X Machina. I'm going to talk about build tools, specifically with Gradle. But I suppose that most of you are familiar with Maven. Who was here yesterday with Robert's session about broken builds? It was a pretty good one, especially the clean install extension. Yeah, that was fun, isn't it? It's great to see that Maven is making new inroads. So, okay, let's get started. My name is Andres, and I'm an ex-Java champion because I'm now an Oracle employee, and I like to travel around the world to talk about different experiences on open source. This is what I'm here. I want to share knowledge, and which means that being an Oracle employee, you have to see this slide. Okay, now that we have seen this, let's get into Maven, which is a tool that most of us know. And we personally had some mixed reactions in the past. Who used Maven since version 1? Let's see, some hands. Yeah, exactly. You know what I'm talking about. And then came Maven 2 and gave us a lot of things like the POM, the object model. The idea behind the POM is that we model everything that we would like to do with our particular project. And the POM file defines two aspects. One is how you build, and also is used for consumers. Whenever the build has produced the artifacts, you will use the same POM file to consume these things. Yesterday, Robert showed us a little glimpse of what could happen in the future with a minimum POM file, or what is called the consumer or public consumer POM file. Anyway, we get a lot of things for free when we use Maven because of the hierarchical nature that it's defined in the POM. We get the clean plugin out of the box and compile resources and a few other things. That's why most of the times our POM files are usually small if we don't have any customizations. Everything stems from the Maven Super POM, which is a definition that only the Maven team can modify. And the strict nature of Maven itself, it's been said by many that it's one of the strongest features, because that constrains how much you can move within a particular project. Some other people believe that is the Maven way or the highway. You do the things the Maven way says, and if you don't, if you want to customize things, then things might not work properly, or you have to endure a lot of pain. That's the reason in the past where the Gradle creators, like 2008 or so, decided to start a new project. They saw the benefits of the conventions that Maven gave us. They saw the benefits of dependency resolution and many other things, but the strict nature of the tool itself was too constraining. So they created Gradle, which happens to be a much more flexible build tool. Instead of using XML, and that's just really an implementation detail, they chose to use, at the time, a full programming language, so Groovy as a DSL, and in recent times, Kotlin. So instead of using supposed to be just a declarative approach with XML, you can use a full programmatic DSL. The definition for consumers are still published via POM files, so Gradle did not reinvent the wheel. It said if it works for Maven, then we're going to use it. But it generates a minimum POM file. It does not generate everything that a regular POM file contains. Because Gradle build files are just that, how you can build a particular project, not necessarily how you will define consumers. Anyway, Gradle build files are highly customizable. Because of the nature of the programmatic API, you can do anything you want. And it's so easy and so tempting that whether you like Groovy or Kotlin, that's not the problem. It's the problem that this is just a function call in order to fix this problem. Oh, this particular plugin does not expose the API that I want, then just monkey patch with a particular thing of DSL, and I'm done, right? So the next problem arises, and you say, well, that particular functions help me, then I guess I can do something again and again and again. and suddenly you realize that your build file is full of programmatic calls, and only you will be able to understand it, not just your teammates. Say that you're fine with this, then you move to another project that requires different constraints. And yes, you will probably start to write programmatic stuff on them, and it will be different and different. So in the end, turns out that many, if not most, of your Gradle builds will be completely customizable. So, can we do something about that? Because it's very, very hard for someone to understand a particular build file like in Gradle and then move to another project, another team, or another organization where they follow completely different conventions. Whereas if you were to use Maven, the similarities within the different builds are very close alike. There are not that many differences. So my question that I asked myself like a year ago is, given the flexibility of the Gradle Build Tool, is it possible to build or to apply a Maven-like structure on top of Gradle so that we can get more benefits? Yes, the tool is flexible, but it's also very easy to understand if we follow a structure that everybody knows. Well, as it turns out, this is what I'm asking. So we turn from something that looks like something that is a Maven build, that everybody understands the sections, and we just move this to Gradle. Can we do this? Well, psych, that thing on the other side is actually not Maven. That is a Gradle project specified using an XML DSL. It's something that is not yet built, but it's possible. But what is possible today is the image on the other side. This is an actual DSL in Groovy, which you could also build in Kotlin if you want to. And this will provide the same benefits as having a Maven-like structure. How do we make this happen? There is a series of plugins out there. It's called the Core and Gradle plugins. The first link is the link to the GitHub repository where you can find the source code. And the second link is to the guide that we have written with ASCII Doctor that explains everything that you would like to know about Gradle or these particular plugins. To begin with, we would like to provide you a DSL for where you can specify all the constraints and all the definitions that might be reused by different plugins. So it looks something like this. There are two ways to apply plugins in Gradle. I decided to use the shorthand notation. And when you apply the project plugin, this brings a host of other small plugins that give you access to all the behavior. So in the info block is where you define properties that will be typically mapped to a POM file, such as the name, the vendor, description. You have links to SCM that may be reused to the SCM block in the POM file. But if you want to publish to, let's say, Beantray Just Center, some of this information can be reapplied to the Beantray plugin that is specific. Or you will see that it's a block for person and it happens to have a role of developer. This will be typically mapped to the developer's block in the POM file. If you were to choose a contributor role, then that person will be mapped into the contributors block on the POM file. And there are many other entries that we can see. When you apply the project plugin, you get all this behavior out of the box. The base gives you access to the DSL and a few additional tasks that we'll see in a moment. Build info captures information about your build, for example, when it was built, who built it, what is the latest hash commit in case that you're Git or Subversion or CSV, and which JDK. And this information could be injected anywhere you want to. It could be a jar manifest, it could be a properties file, it could be any resource under your control. The jar plugin right there is the one that actually enriches the manifest with this information, which can be toggled with a flag. When you publish to Maven Central, you have to follow certain rules, which means the POM file has to have certain information, but also you have to provide a Javadoc jar and a sources jar. Well, the Javadoc plugin and the source jar plugin gives you these capabilities. If you need to format the license headers with using a particular header and making sure that these headers get updated every year, then the license plugin can do this for you. Another thing that the license plugin can do for you is generate a license report of all your runtime and compile time dependencies. I don't know about you, but in the past, my customers have asked me if the particular product that I have built for them has any relationship with viral projects or viral licenses. For example, the most typical case is GPL. In the past, what we will have to do is go through every licenses and try to find on the web. But if you apply this plugin, just invoke a command, and this will generate the report for you. Or if you happen to use code coverage, then Jacoco is probably the best tool that you can choose out there. There is a standard Jacoco plugin from Gradle, but it does not generate aggregates at the root. Well, this one does it. And there are a few more other things that we can see. So the base plugin, besides the DSL that you saw, gives you access to more information about your build. The tasks that you see here on the screen are those that are coming by default Gradle. The list of projects, a list of all their dependencies, the list of all properties, regardless if they are project properties, command line, or your local properties. And of course, the list of all tasks that can be invoked. But what else can we ask a build? Would you like to know how many source sets, or the current Java compiler settings, or configurations, or publications, or whatnot? So this is exactly what this particular plugin tries to address. Say now I'm going to run into the terminal. So let's move there. I have already a project that has applied this list of plugins. So I'm going to make a list bigger. And one thing that I want to do is ask, what are the settings for compiling this particular project? So I can ask for the Java compiler settings. And this will give me the information about production classes and test classes. So in one side here, we say this project is going to compile against 1.7, Java 1.7, and it's not verbose. Have you ever had troubles with class path? Finding out if a particular class is in certain order or not, right? Okay, do you want to know which order the class path is going to be constructed? Just pass show paths to this call, and it will tell you what error. Oh, I say publication settings. Oh, that's weird. No, that's not the one I want to do. I want to do Java compiler. There we go. Show paths. Here we go. And this one says for the production classes, these are the actual jar files that will be put in the class path in that order. If we were to run the test classes, then our production classes come first, and then the rest of the jars. If you were to run in modules, when things will be different in the terms of the class path. Another thing that we can ask this particular project is publication settings. So how many artifacts will be generated? Well, it turns out we have the javadoc jar. This is our binary, but also we have sources and javadoc using certain coordinates. We can also ask how many plugins we have currently applied, and we have actually 33 because we start counting from 0, like everybody should be doing. There is 33 plugins. You get the idea of the plugin and the class. If you want to know what kind of behavior is exposed by the plugin, then you can search for this class if it's not documented. You can also ask for all the extensions, which happen to have 14 of them. And here is the config extension. This is the one that enables the project DSL. So if the guide were not to be documented properly, you can just Google out for this particular class and find all the properties and methods that the DSL gives you access to. You could also say, for example, list all the projects. This is a multi-project build. And this will tell you actually have 3 projects, the root, and 3 children, guide and core. I can also ask for all the properties, something like GW, list properties, and I'm going to define a new property, for example, conference equals debox. So this is a command line property that I just defined. What? List properties. Yeah, typo. There we go. What? What's going on? List props. Whoop. It's project property. Sorry, I'm using the wrong command, and I show you in a moment what it is. So I can do just project properties like this, and it tells me everything. The static properties from my project. These are properties that have getters and setters on the project instance, but also all those properties that are coming from many different places. You can see that there are colors being used here. Cyan is for numbers. Magenta is for secrets that I'm not going to show, but if you wanted to see those, just add -- show secrets. Yellow is for strings. Green and red are for booleans, and somewhere there is conference. There is debox right there. So it takes all the properties. And what else we can do here? In Maven, when Maven builds your project, it actually has to resolve what is called as the effective POM, which means the settings that you currently have in your POM file, plus everything that is coming up the parent chain, all the way to the Maven super POM. In this particular project, in this DSL, we also have something similar to that. It's called effective settings. And with this, you can have a look at everything that might be configured with these plugins. Let's see. There is the information right here at the top of our project. So the name, the description, copyright year, authors that will be taken into the licenses, the different people. Some have role developer and author, some others have role contributors. Then some repositories for publication. These are local repositories, SCM, and publication for Bintray, which is reused for the info block that we saw earlier. This is the build info information that I was telling you about before, and a few other things like Jacoco and Javadoc and blah, 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 blah. There are so many things that you can configure. And one more thing that we can do here, I think, let's do a clean. No, yeah, let's make sure that we run everything. We run test. Make sure that we are not running with the cache, because I always have local cache enabled to make my builds faster. So what I want to show now is another addition that this plugin does is enrich the console with this test output. For every test that is run, it will show that if it's green or not, so everything is fine. How many tests were run? 5 in total. The number in green tells me how many there were successful. So 5 successful. In red, if any failures, and in yellow, if there's anything that was ignored. At the end, it will make a full report of how many of them were executed. Well, this is nice for the console, but you could do, let's look at all the tasks that we can run from the Json-lib core project. Let's do tasks.all. And if I'm not mistaken, in the verification group here, we have a new test, a new one that says all tests, and this will run everything, whether it's unit test case, integration, functional, and generate an aggregate report for everybody, which it will be either XML or HTML. More stuff that we can see. The insight group is also provided by the base plugin, and this is the one that gives you insight into your build. I already show effective settings and project properties, but there is also, for example, source sets or repositories that you're going to use to publish artifacts. Or, for example, if you were to use a Groovy project or a Scala project, you can also get Scala compiler settings or Groovy compiler settings, and a few more other things. Okay, let's go back to the presentation. Yeah. And in case that the demo broke, which didn't happen, there are some screenshots on the list of repositories or the list of extensions or the list of plugins or some other things that you can ask your build for information. There are more plugins, but these you have to apply specifically because it does not make sense for all projects. For example, if you're using Kotlin and you want to generate a Javadoc or something that looks like Javadoc, there's a project out there called Docker. And we apply the same ideas that for the Javadoc plugin and GroovyDoc. So the information that you define in the info block in the DSL can be reused to configure the generation of the Docker documentation. So that's Kotlin doc. The same way it works with Scala doc. Or if you're familiar with the JXR plugin from Maven to have beautiful documentation that you can link from one another, well, the SourceXRex plugin does this for you. Or do you need to calculate binary differences within two different releases, your current release and the past? Then you can use Clear. Or you can use Guide to generate an ASCII Doctor guide, which is kind of exactly the same way as we generate the documentation for this particular project. And well, that concludes the list of... There's one more plugin that I'm going to show in just a moment. But this is basically the universe of configuration and behavior that you get if you were to apply these particular plugins. So now let's turn into what is, again, the super POM from Maven. The advantages, again, POMs come in a hierarchy. And it's a good thing because in a parent POM, you can define behavior that any children can leverage. And this hierarchy goes all the way to the top, to the Maven super POM. And in Gradle, we don't have something like that. There is no default way or single way, actually, to do inheritance from project to project. You could include a script if you want to, but that gets a little bit troublesome with versioning and availability of these particular scripts. And also, again, it becomes like a programmatic stuff that someone eventually has to understand. But we can fake this. We can fake a parent POM in Gradle by just creating a plugin. It could be any plugin. It could apply any conventions as long as it makes sense for your particular project or your particular organization. So here, let me show you an example of that. I have built a project that I decided to name Cordan Parent. And this project is built also using the Cordan Gradle plugin. So now I'm going to show you the build file for this particular project. It applies the project plugin. It applies another plugin that allows me to publish Gradle plugins, reusing all the documentation and information that I have configured. Then here comes the info block. Yeah, well, author and people and repositories and configuration for GroovyDoc because this is a Groovy project. Information about the license. We support all the OSI standard licenses, but if you want to use a custom license or a commercial license, you can configure it as well. Publication for publishing to bin tray. And this particular plugin will apply the Cordan plugins again. What I want is my consumers to be able to reuse Cordan with certain conventions. So the class that defines the plugin is right here. This one applies the project plugin again, bin tray, and some default configurations such as these properties and vendor and links and auto and whatnot, these things. Okay, so far so good. So what I'll do is publish this as a standard Gradle plugin and then consume it from another project. For example, the Json-lib project here. It applies that plugin, the Cordan plugin, parent POM, the latest version is this one, and it defines name, description, and some other things. Notice that it did not define the vendor. It did not define my name as a developer. And of course, it didn't define the license here. The only thing that we see here is SCM is different, the repositories. There's no information about license, right? So when I go back to the command line and look at the information from the effective settings, look for the license block right there, Apache. This is coming from the parent POM plugin. Moreover, the Cordan vendor, which is right there, is coming from the parent. My name, coming from the parent. All those things you can reuse. So if it makes sense for you to create a parent POM or like a super POM using Cordan, sure, why not? But you can also apply any other kind of plugin that you deem necessary. Okay, let's continue. Moreover, one more thing that we can look at is file structure. There are many ways that we can structure our projects, but I will recommend to use at least 3 ways. One, there are no names, and I just made up these following names. One I would call the standard one, because most of the times when we execute examples, the children project are in the first level directory. So for example, what you see on the screen, guide, project 1 and project 2. The default naming convention for the build files is build.gradle or build.gradle KTS if you happen to use Kotlin script. One thing that I don't like is when I'm editing a file, and if I'm not using an IDE that is smart enough to put the name of the project on the tab, then I will get in trouble if I start to edit build.gradle or pom.xml without knowing exactly what project I'm changing. So one thing that you can instruct Gradle is to use a different name for the build file. In this case, it matches the project name. But if you change the convention, you have to tell Gradle about that. And there's a little bit of code that you have to add to the settings of the Gradle file. If you follow the conventions, just apply the code on the right side, on the left side. But if you want to change the name of the project file, then you have to do the other thing. So for 3 projects, it's not so bad. But if you have a big project with lots and lots of modules, this is going to be a problem, right? Or you can apply another plugin called the settings plugin, which is aware of this particular convention. Not only that, it's aware if you want to use Groovy or Kotlin DSL, so it understands the different extensions. If you want to use the naming convention or if you want to forego. So just give it a layout standard and it knows exactly what to do. Or say, for example, you want to use a different structure, 2-level structure, when you put all the subprojects in a particular subdirectory, and say guide goes into docs, and maybe we have manual or something else, and then we have subprojects or plugins or extensions, what have you, what makes sense for your organization. Again, we could have build Gradle or the name of the project. We will have to tell Gradle about the different conventions, or apply the settings project, say that you want a different layout, in this case 2-level, and you also want to constrain the search of all the directories. By default, it's going to be everything in your current root, or you want to say it's only within docs and subprojects. If you happen to have, I don't know, apps, plugins, or extensions, and do not be part of the project for the time being, then just don't list them there. Finally, we have a combination of the last 2 ways. First level, second level, third level, or nth level. For this, we will have to tell Gradle about the locations for everybody and the changes for all the names. Or simply apply the settings plugin, list the paths to all the projects that you want to have, and be done with it. And that would be it. So, everything that we have seen so far is open source. And if you have not contributed to open source before, let me tell you that it's so easy. You find a problem with any open source project dependency that you're using on daily work, file a ticket. That's it. Nothing else. But if you have the time, you have the passion, submit a test case or submit a patch. But at the very least, just file a ticket, and that is plenty of good that is coming to us developers. So I discussed a lot of things today. I hope that you see Gradle in a different light. It's possible to flex Gradle to do your bidding instead of making your life misery because the tool does not understand your own conventions. I discussed these things and a few others in this particular newsletter. The first link is in English. The second link is in Spanish, which happens to be my mother tongue. And yeah, feel free to subscribe if you want to. So I hope that some of you are now feeling like this, like, oh, yeah, I didn't know that Gradle could do that. Well, yes, actually you can. And getting started with Gradle plugins is actually an easy task to do. So thank you very much for your time. I'll be still around in the conference in case that you want to grab me. I'll be at the Oracle booth. You can ask all kind of questions, and I'll be very happy to answer this. So thank you very much for your time. Keep enjoying DevOps.